Hi, my name is Anindya Carmelya, and it's one of the requirements for publication in Indonesian Journal of Electrical Engineering and Computer Science. Here, I'm excited to present you our paper in the next 15 minutes. So the title of our research is SRCNN-Based Image Transmission for Autonomous Vehicles in Limited Network Areas, with our paper ID number is 39333. So the background of our research is we know that high quality images are crucial for autonomous vehicle functions, such as for navigation, obstacle detection, and environmental understanding. Transmitting high resolution images for constrained networks presents significant challenges due to bandwidth limitation. And the objective of our research is to develop an image transmission system using super resolution convolutional neural networks, or SRCNN, to enhance image quality without increasing bandwidth requirements. So this is our research motivation. So our research motivation is to enhance image quality received by autonomous vehicles without increasing bandwidth requirements. And furthermore, to ensure critical visual information is preserved while minimizing data transmission loss, especially in scenarios with limited or unstable network bandwidth. This is the methodology overview. So the methodology of our research is to use SRCNN to upscale low-resolution images transmit over constrained networks to high-resolution images. Three SRCNN model configurations, such as 915, 935, and 955, were tailored to the specific needs of autonomous electrical vehicles operating in limited areas. We can see in this figure that low-resolution image is transmitted using transmitter, such as LoRa, and being received by the receiver. After that, the SRCNN process begins. So the low resolution image that has been received by the receiver is being upsampled using big interpolation. And the big sampled version is undergoes to the three convolutional layer of SRCNN, such as patch extraction and representation, nonlinear mapping, and reconstruction. And after that, we can obtain the high resolution image from the original low resolution image input. So this is the phase one of our research, data acquisition. So the location where dataset objects capture is at Science and Technology area, Samaun sama di Brin Bandung. To capture these objects, we use 4K boost lens camera. There are 15 videos obtained and they are converted to frames, resulting in a substantial number of frames divided into training set with 348 images, validation with 157 images, and last but not least, testing steps with 55 images. So this is the phase two of our research, model preparation and training. So the training steps we use in this research are 200,000 steps with Adam as the optimizer. Training metrics that we use in this research are training loss, validation loss, training PSNR, and validation PSNR. Filter size used for the 915 model configuration are 9 by 9, 1 by 1, and 5 by 5 across all the three convolutional layer of SRCNN. This is same for the other two model configuration, like in the 935 model configuration, we use 3 by 3 filter size at the second convolutional layer. Same for the 955 model configuration, we use 5 by 5 filter size for the second convolutional layer of SRCNN. This is the result and discussion for the phase 2, for the training phase. So the model 915 presents quick learning and stable performance with high initial loss. We can see that in this figure, the training and validation loss for this architecture is the failure is dropped far before the loss failure is dropped before the 50,000 steps. It's same for the train and validation PSNR that the PSNR failure is increased and reach its peak at the before 50,000 steps. This is the result and discussion for model 935. Model 935 tends to rapid convergence, but kind of potential overfitting. So we can see in this figure, the training and validation loss value is dropped near the 50,000 steps. Same like the PSNR value for the train and validation. The values are increased and reach its peaks near the 50,000 steps. Last but not least, for model 955, that provides the most reliable and effective configuration with high initial performance. Based on the figure here, we can see that the loss value for the training and validation is dropped far before the 50,000 steps. Same like the PSNR value that increase and reach its peaks far before the 50,000 steps. So this is the phase 3 or the last phase of this research. It's model testing. So the evaluation using testing datasets, that this dataset has 55 images, metrics that we use to measure the model performance is mean PSNR. Moreover, images scaled in 3 different scales, such as 2 times, 3 times, and 4 times. This is the table 1. There's also table 2 and table 3. And across all the 3 scales and 3 model configuration, we can see here that the scale 2 has the biggest PSNR value with the value of the average. The average is reach 33.655. So it's around 33 decibel for the average, but for the maximum value, it reached 35, around 35 decibel. So this is the comparative analysis across all the 3 configuration models. So model 955 is the best and the most consistent performance across all the scales, followed by the 915 model configuration that has a strong performance with some variability. And last is model 935, has consistent mean values, but also the lowest minimum value. So this is the sample input and output. We can see at the left side, there's a sample of input image. And on the right side is the image output given by the model configuration of 955. So this is the summary of the conclusion of our research. SRCNN is effectively enhanced image quality for autonomous vehicles operating in constrained network areas. Model 955 emerged as the most reliable and effective, showing superior performance and consistency. With the input image resolution is 170 square pixels. The same model could scale the image to 510 square pixels with PSNR value of 30.926 decibel, and the resulting image appeared good. Transmitting this transmitting these images over the IEEE 802.11ac Wi-Fi network will prove efficient, but using the LoRa network will introduce significant delays with 128 square pixels image will take 5.6 seconds. So I will say thank you to Indonesia Endowment Fund for Education or Lembaga Pengelolaan Dana Pendidikan through the Riset dan Inovasi untuk Indonesia Maju program organized by the National Research and Innovation Agency. So this is the end of our encounter. I hope this video is giving you a better understanding of our research. I hope we can meet again in another time. Bye.